longtime friend of mine personally, from Checkmarks, talking on serial killers.
Thank you very much. So welcome everybody. My talk, the serial killers. I apologize for the name. It's a stupid, stupid name. I was made to come up with one very short notice. That's the cleverest thing I can think of, so that can tell you a lot about me as a person. So on our agenda, we're going to start with introduction to deserialization and serialization in general, the concepts, the use cases, the real world scenarios. Then we're going to move on to some language and frameworks, attacking them, exploiting them. Finally, we're going to go into some built-in deserialization attacks. And finally, we have conclusions, some best practices, some general concepts about mitigation. So I'm assuming that you will enjoy this most if you are familiar with coding practices, patterns, some concepts, are familiar with some fundamental exploitation and payloads and the entire concept. If you are very, very chill, because I'm going to lie to you a bit and oversimplify some concepts just because I have 45 minutes for something we can talk about for hours. And if you can go fast, because we're going to go really, really, really fast, at least at some point. So, a little bit about me. I've been a research team leader at Checkmarks for the past couple of years. I'm formerly a consultant for Cisco's advanced services. I've been doing red teams, pen tests, pretty much constantly for the past 5 years before Checkmarks. Again, 7 years actively poking at stuff and watching it burn. I am the father of this gorgeous and crazy little girl and this gorgeous and crazy little dog. I don't shut up, you're gonna notice. And my opinions and any naughty words that slip through, because I swear a lot as a person, so those are my own and not my employer's. Without further ado, Wikipedia. So Wikipedia defines serialization as the process of translating data structures or object state into a format that can be stored or transmitted, reconstructed later. That is a very, very good definition. That is a very, very good definition of the concept as a whole. It's a very succinct definition of what's going on, but that's just the core idea. Now me, I'm a technical guy. I want to see what I'm talking about with my own two eyes. So there are pretty much 3 subcategories. There's the language native stuff that is proprietary per language. Here we can see the object stream from Java and a pickle from Python. There's the generic types that we all know and love, CSV, JSON, XML, YAML, all those types. And there are the specialized ones, which are kind of out of scope for this talk, so we won't get into them. So, a serialized object is intended to be transmitted over a network or stored in a file or written to an output or whatever. It's basically a stringified form of a memory construct. And most standard serializers will work with pretty much anything that is native to your language, to your framework, and then can themselves reference objects in your own object space. It's a pretty big concept, but it's also a very simple one, and we'll get into that later. So I think that the most apt comparison is soup in a cup, or manachama. Imagine trying to transport a bowl of soup from place to place. So you take the bowl of soup, and you have this ingredient that makes it very unstable to transport. You take the soup, and you dehydrate that into a powder. You even put it in a bag. I don't have any soup sponsors for this talk, but if anybody wants to talk to me about that later. So you take the powdered soup, you can put it in a warehouse, you can put it in a supermarket for distribution, and you're pretty much transmitted your soup across the country. You want your soup back, you just add water. And again, I'm a technical guy. I don't trust my own stupid metaphors, stupid and lazy. So here is a very simple basic demo of serialization. So in lines 1 to 4, I define some primitives. I build this class called a testing class using these primitives. Then I build my serializer. I'm using Xstream, which is a very common serializer. It's built into Jenkins. It's built into struts. It's pretty much everywhere in Java. And I print it out as an XML to output. And let's see what we get. Something very predictable We have all the variable names and their values, and it's wrapped by the class itself. And this format can obviously be transmitted very easily. It's a string. It can be stored. It can be put in a database. Taking the XML and reconstructing it is just as simple. I take my serialized testing class, and I use Extreme from XML to read it back into an object form. So running the getName method on my testing class will simply return the name that we've stored earlier inside the XML. The most significant thing that we need to consider, and pretty much the only thing we need to consider at this point for a simple, naive serializer, is that on both ends, like the sender, the serializer, and the deserializer, there has to be a match, at least in class structure and variable names. Otherwise, you're going to get errors. But that is pretty much the only consideration you need for a serializer to operate as intended. When it comes to real-world scenarios, we have things like APIs. For example, Struts2 API has a REST API that works with XMLs. And it uses a serializer to just break down these XMLs back into objects and transmit them to the client when needed as XMLs. If you have an application, a video game, you want to save your current state in the game, why bother with trying to track every single variable? Just serialize your state, save it to a file, load it later. And for distribution of workload, it's also pretty great. There are a lot of samples or instances of Python code using to distribute workloads by pickling, which is the Python name for serialization. It's cute, stupid, but cute. And there are just so many real-world use cases for serialization. Isn't it great? Isn't serialization amazing? Well, let's rewind a bit through everything we just said and focus on this little slide. So this guy right here is money. Because being able to reference pretty much the entire class space when using a serializer that is configured naively is awesome. And we'll go into that in our exploitation segment. So before I start, obviously, most of this is not mine. There are a lot of people to acknowledge. Chris Proha for his work on Java, Alexander Mirosh and Alvaro Munoz on their work on .NET, as well as James Forshaw, and Manu Mo, who did some excellent work on struts, and we're going to go into that a little later, as in right now. So Struts2, I bet you're familiar with that web framework. They are elegant and modern and use convention over configuration, and they're a garbage fire. They're a garbage fire because if you've heard of the Equifax hack, these guys and their coding patterns, we're not going to talk about that. We're going to talk about a completely different code execution attack that was available on Struts that very same year. So without further ado, first demo. On the left, we have our Struts2 server. On the right, we have the REST API with a web application, and we create a new order, and it's created right here at the very bottom. Sorry, I'm going to zoom in soon. So we have our new order, and this is what it looks like in Burp. We send our XML, and voila, a new order has been created from XML. But what about this little bad boy right here that we have, which is wrapped in a hash map and contains all these sort of neat little objects? What we're most concerned with is the innermost object, which is process builder, which is a call to start on process builder. So here we go. Send it to the server, and we get an error 500. I wonder what happened. So this is the object that we sent. This is a gadget chain for Java. We're going to go into that a little later. It's based around Apache Commons, which is very popular. It's built into Struts2, so it doesn't. This is out of the box, mint, vanilla Struts2. And it's interesting to see that it's actually very difficult to detect heuristically because, well, it's an XML sent to an interface that expects to receive XML. So it's very unlikely that you could heuristically determine which XML is malicious and which one is expected. So back to our little demo. Let's check out the server. And we got calc. So seeing that we have calc on the server is very, very nice. What just happened? Well, the naive deserializer implemented by Struts2, which is extreme, by the way, it doesn't do any sort of validation, doesn't do any sort of restriction on what objects it can or cannot deserialize. And this is its constructor for that extreme serializer or deserializer in this case. You can see it just returns a new object. This has been fixed since, obviously, hopefully. As you can see right here, the first thing it does is it adds the none permission, which means it revokes it, and then it starts whitelisting additional objects that can be deserialized, which is a good approach. So let's talk about that gadget chain I just showed you. A gadget chain is basically an instance of an object saved into memory, which may contain its own sub-objects, and it sets the instance variables from the XML, and some instance methods are automatically invoked. This is the call tree for the invocation of the gadget tree the gadget chain we just saw. It's a bit complicated, and because we're going to talk about a lot of different serialization attacks, I'm not going to go into every single call right here. But the interesting thing to understand is the cascading effect between the very external object, which is a hash map, and what it does is once you create any entry inside a hash map, you hash the key. So it calls hash code, which goes to native string and tries to get the value string. And then it goes to toString. Then it goes to base64, which has a cipher. The cipher tries to choose a cipher despite being a null cipher, and then starts iteratively calling any internal members. And that sort of leads us to our payload and, magic. So this is very complicated. I had to read a lot about it, so it's not something that I feel like is in scope to break down. But it is important to see a gadget chain because it's important to understand that they could get very difficult to design. They must live off the land. They must have available classes. They must have available objects. Everything needs to correctly connect for all these calls to happen correctly. It must parse, obviously, because otherwise it's going to fail before it even starts to deserialize. And it's important to understand that it doesn't always have to complete deserialization. It can error out, but all I care for is that my malicious object inside this nested object gets deserialized properly, executes code. What happens later, I don't care. So this is how Struts2 was owned last year. Let's move on to .NET, because if you do something right in Java, you should also try it in .NET, obviously. Let's consider the following code, which basically just calls JSON convert from the very, very popular JSON.NET library. If any one of you does .NET and uses JSON, you know of it because the built-in Microsoft parsers are just not robust enough to create a proper dictionary out of a JSON object. And, it's going to behave as you would expect. We're going to pass this object to it, like this order object with an order ID and a user ID. We're going to print those out, and it's working as intended. But, cool. What would happen if we pass this guy to the same exact code? So we have this object data provider. It's a form of wrapping in .NET for objects, making a static call to process start with calc as our payload. And this is the exact same code as we saw before. And as soon as we press enter to parse, pop, calc. And there's a little exception down there. We're going to go into that as well. So it is possible to safely deserialize using JSON convert. But this is the bad form. Here, we cast the object after we've deserialized. The good form is using generic notation, not because of any general pattern, but because that is how this specific object uses serialization to properly determine a type. So the implementation uses the generic notation, and when it doesn't get that object it expects to the T, it simply fails and throws an exception. But as we saw before, if you cast, then that happens after deserialization, then you're screwed. So there are ways to pass multiple types to this specific object. That's not very interesting right now. The bigger issue is that implementation is super vague, because if you have generic notation and casting, it sort of looks the same. I mean, obviously there are major differences between the two, but when you're just thinking or just reviewing code, it's quite unclear and quite confusing. So what exception was thrown? The invalid cast exception, which is as to be expected. We passed an object and it deserialized successfully, and after that, it tried to cast. So casting occurs after deserialization, which means it's way too late. So we got this calc going on .NET. So we have a pickle demo as well. It's used to contain a pickle Rick meme, but that meme is dead. I killed it. This following Python code is very, very similar to our .NET example. We have a trade object with instance variable of broker ID and user ID. And when you try to dumps a trade object, you get this ugly thing, this barely readable thing, but that's a pickle for you. That's their format, and it works. And somewhat more readable than Java byte stream. So let's deserialize this object. And again, we get this boring result where we got the broker name, the instance variable for broker. And as you would imagine, that strictly typed languages have an advantage over untyped languages or implicitly typed languages. And the explanation is pretty simple, because when you're working dynamically without any sort of acclimation for objects and object types, you don't take the typing into consideration. And untyped languages just don't have these methods for sniffing out or trying to determine class before deserialization. You could probably hack something, but it's going to be difficult. So let's consider these Windows and Linux samples. And again, we have this unpickling code right here. Press enter to pickle loads one of the objects from before, and boom, calc. So why is it so simple in Python? Python has a method, or a native method, for every object called reduce. Reduce produces a pickleable form of a method and an argument, or it could if you wanted to. And then when you unpickle, it simply pops that method with those variables, and you're good to go. Basically, it's spring-loading code, code injection bombs, and that's really, really nice and simple and easy. So that too is own. PHP is an interesting animal. I say this because, first of all, unserializing, it's not deserializing, it's unserializing, you guys, invokes specific methods. It creates the object from reflections. There's no constructor. It sets the instance variables and, starts going until the object reaches its end of life, or the cycle, and then destructs. Why is this interesting? Because its own design pretty much saves it. First of all, any sort of built-in functionality that we've seen before, like system or Java-Lang runtime, is not a class in PHP. It is a language construct. It is a method that is baked into the language. Classes are actually something that was added on top of PHP rather than be the very core of it like it is in Java and .NET and Python. So all of these things are not part of any class that you can serialize and invoke and do all these fantastic things with. And that basically means that we've whitelisted all of these dangerous built-in methods, invocation types, or whatever. Doesn't mean it can't be exploited. It was just exploited 2 weeks ago with an unserializing attack that sort of bypasses a lot of mechanisms for PHP and invokes unserialization, which allows you to call arbitrary classes. And if you have a big enough code base, you're going to have some dangerous classes in it. And so it can be exploited, but it is very much contextual, way more contextual than anything we've seen with Java and .NET, which have a wider berth of classes that you can call from serialization. Anybody know what serialization in Go, what serialization attacks in Go would look like? Any Go devs here? No? Okay. So there are no deserialization attacks as of yet against Go. Why? Because it doesn't really use classes. It has structs. And when it populates the structs, it doesn't run any code. There are no magically invoked constructors or unserialization methods. It just takes the data, puts it in a struct, and you're done. So it doesn't really work like that with Go. So going back to the actual exploitation that we saw, there are very noticeable common threads here. Well, the idea is streamlining, taking a string or a byte stream and converting it into an object. And it's dangerous if you naively use it on data that you don't trust. That is to say, there is pretty much no such thing as deserialization attacks if you can't control the input. And remotely, if you can remotely deserialize an object, trigger deserialization, you're golden. There are a ton of RC examples, and we're going to talk a bit about them later. So locally, you can trust your deserialization. And if you have some control of the entire channel of deserialization. But if you really wanted to, you can probably figure out an alternative API for deserialization, like building a native constructor that knows how to parse an XML and construct an object without going through all these reflections and deserialization methods. It's not like there are whole technologies designed to distribute objects via serialization, right? Right. That joke barely lands with anybody, so you should feel okay with it. So, message queuing. It's exactly what you would expect. The publish subscribe paradigm or whatever. You have a queue of messages. Somebody publishes messages to them. Others retrieve these messages. This is a very common pattern for distributed workloads or transportation of data inside large organizations. There are a bunch of agnostic MQs. We're not going to talk about them, like Rabbit, Kafka, that don't concern themselves with objects or anything. They just transmit the bytes. You do whatever you want with those bytes. But some of them are great for sending objects. And they do everything. You simply submit an object to your message queue. It serializes it, publishes it. Somebody subscribes to it, deserializes that on the other end. And, you know, are they basically RCE delivery systems? Kind of. Depends on your implementation, as always. So Java's JMS is very well documented as vulnerable. There are a bunch of exploits. There's a really good talk from 2016's Black Hat, boning your Java messaging, which includes a lot of samples, a lot of demos for exploitation of the Java message queue. That's, you know, But as we said before, if you're going to do something right in Java, you should try it again in .NET. And that's where it gets interesting for us in our research. .NET has MSMQ. That thing is ancient, and very much still in use. It's a Windows feature you all have in your Windows VMs. You don't use Windows, right? Which you can enable. And this is kind of what a message looks like when it's waiting in the queue. This is you can even recognize some magic strings from .NET, like the culture and public key token and everything. And it uses two formats to perform serialization. You have XML and you have binary. So that made us embark on some classic research. And the only reference we could find to MSMQ exploitation is actually through these formatters we saw in one of the previously mentioned lectures, a reference to binary message formatter using binary formatter, which is known to be vulnerable, very, very, very vulnerable. So we deep dived into that. Yes. And we went to MSDN and tried to see what this message formatter does. So apparently it's very efficient, it's fast to parse, it's faster throughput, it's pure speed. It's really, really fast. You know how fast? Too fast. Which brings us to our demo. This is code copy-pasted straight off of MSDN. This is code for receiving a message with MSMQ, with the binary message formatter. Remember, it's one of two and it's really fast. So I sort of yoinked this out of ysoserial.net. Excellent tool. Go visit it on GitHub. And wrapped that object around, with a message and sent that. So this is basic MSMQ code, just sending and receiving. We sent the message to the queue and pop. It was very easy. Don't clap. So, and hello there. Same exception from before. So, MSDN samples being vulnerable, not great. Is this enough though? I mean, it's not really CVE material, right? Maybe it's just bad because they wanted their samples to be small and agile. So we went ahead and dug through some more Microsoft sample code. This is their large message queue sample from GitHub. It's right there in that nasty little link. And this is what it looks like. It's a Windows, the form application. You have a queue in the middle. You submit a BMP file. You read the BMP file. That's what the demo does. So I took the same code, started that app, just send something to the queue to see what's going on. Then I sent my own nasty little message to that queue. And when I hit receive, well, yeah. So, going back to that code, as soon as binary message formatter is set, on the very next line, body of a message is dereferenced. And as soon as you set over body, it's calc o'clock, baby. So, when we tried that, we did it with .NET 4.5 because it's easier to take that project from Microsoft and bring it over to .NET 4.5. But what we did find after some research is that there are some ways to convert some deserialization attacks back to .NET 3.5. This is one of them. This code is vulnerable all the way back to 3.5, meaning that anything using this from 2007 is vulnerable. So I'll give you some context about that later. MSMQ with binary message formatter, exploitable by default. Cannot explicitly set types. There is no way to set types for that thing. And it's intended for remote use. It's for the publish-subscribe model. So really can't dodge that one by saying you should use it safely because it's intended to be remotely accessible. In what scenarios would we expect to find it? Well, not GitHub, but it is used for sending larger messages at a fast throughput, and you're mainly going to see it in backbone systems, and specifically older backbone systems where they use Microsoft's message queue as part of everything related to Active Directory activity. So while you won't find many projects about it, you will find it. I hope you never find it. Please don't find it, but let me know. And we did see it in some workload distribution code. I know that BizTalk from Microsoft supports MSMQ for transmission, and some other tools that are out there. It is also highly recommended in O'Reilly's C# 6.0 cookbook. It's not that old. It's actually from 2015. I bet that they want to have a new edition soon. You can see there's a message body right here, which means it'll pop the calc. We also found it in this book, this book, this book. And my only conclusion is, don't read books. Try my best, by the way, to not read a book. So when we confronted Microsoft with this, the response was, would not meet the bar for security servicing. No longer monitor, whatever. Okay, fine. So they're being dense about it. And, that sucks, but we own them. So people were actually really good sports about it. O'Reilly, they were also good sports about it in Black Hat when I went over to talk to them about it, and they gave me a book. So that's very cool. I wouldn't read it though. So they were like, thanks for letting us know, and we're gonna post it back to the editors of those books. So talking about some additional risks in deserialization. So far, all we talked about was using naive or stupid serializers, but there are a lot of other interesting facets to it. So deserialization is quite cheap, but not that cheap. So if you can nest something that is supported by the deserializer but would eventually break, you can actually flood it fairly easily. That said, DDoS is not interesting, so moving on. My opinion. And a really interesting facet to deserialization is the way that it doesn't always adhere to what you think it would. So consider that when you are deserializing, you're basically building something that might have private variables or complicated variables. If you deserialize something and you have some logic in those things, then the deserializer isn't working right. I mean, if it goes through some logic that alters the data that you're trying to deserialize, the object you're going to get at the end is not identical to the serialized object. Okay, good. So a lot of deserializers simply ignore constructors or ignore setters. Or in other words, if you have any sort of logic in your setters or your constructors, it might not be enforced as you would expect it to. For example, if you have a user ID number, you wouldn't expect it to be minus 500, but it could be if your data type is integer. And if you do those checks in your setters or your constructors, it might not really follow through. And that would allow deserialization to bypass a lot of application logic. And that's also a very interesting perspective, but again, that is way too contextual for this talk. So from an industry perspective, there was the great deserialization apocalypse of 2015, 2016. A lot of really, really, really serious vulnerabilities in a lot of framework platforms. Some of them were unauthenticated and were therefore wormed for the purpose of mining Bitcoins. It's very boring when you can steal all that data. But there's a lot going on that front. When it comes to OWASP, it's part of the top 10 now. Yeah, no? So used to be A1 injection, but obviously catching all that media buzz and all those industry tiers was important. So from a CIA perspective, you got a lot of 9.8s and 10s. It's just, there are so many interesting things to go through, which I'm not going to go into this talk. And that goes without saying that these are the ones that have RCE, but there are so many things that haven't been taken into consideration, like I mentioned, corruption of objects or dangerous objects and denial of service. But a really interesting quote that I came across is that Mark Reinhold, the chief architect for the Java platform at Oracle, said that Java serialization was a horrible mistake they made back in 1997. Now, it might be. That said, Oracle is planning on dropping serialization support in Java sooner rather than later. And in my opinion, this does not matter. This does not matter in any way, because if you tell me that my code stops working, my entire enterprise's code stops working if we rely on serialization, if you tell me that updating my Java would break everything, I ain't gonna do it. You ain't gonna do it either. So it's kind of a bad idea. I think it's sort of something that needs to be a lot tamer in the sense of how you undo serialization in Java. Otherwise, it's completely crazy. So mitigation do's and doesn't. Let's consider what is a bad idea first. Catching exception from a failed deserialization obviously means that we've gone way too far and it's probably irrelevant and you lose. Assertions are basically pretty exceptions, so no need to go into those. But what is worth discussing is how to fix your serialization issues. First of all, if you can, do not trust data that comes from users. Don't. Not opening a file, not receiving a message. Don't trust it. That's a very easy solution for me to say, but I guess some might need to eventually. So in untyped languages, this is even more so the case. There is pretty much, there's a lot of issues with deserialization in untyped languages. And also the idea of untyped deserializers. As you could see before, the declaration in struts 2 for extreme is an untyped deserializer. There are no strict types that it is allowed to open. It can open all of them that are available to it, and that is a risk. So there's also the concept of dangerous types, which even goes so far as to attack languages like PHP, which do not have any inherently dangerous classes, only inherently dangerous functions, and yet you could create a type so dangerous that you would shoot yourself in the foot. So always, obviously, always goes without saying, always whitelist where possible. So test your deserializers even when you use a whitelist. What if your deserializer only whitelists the topmost layer and then doesn't any? Cool. So always make sure that your deserialization fails before object creation. Anything that you do after the deserialization call is meaningless. And when you control your setters and constructors, always check that your deserializer goes through all that logic. If it doesn't, you're going to have to re-implement it, but you would be wiser for it. And if you're still paranoid, you could try building your own transformer. Just parse the XML, pass it on to a normal XML. It's going to have poor performance because serialization is going to be way faster than your code. It requires work for every single type that you work with, and it's only secure if your code is not bad. So that's up to you guys. In conclusion, deserialization is kind of awesome. It's very cool. It solves a lot of problems very easily. But is it too awesome? Maybe it's too awesome to exist in this horrible world of ours. And it's a classic example of things being automagical. Things just magically happening with people not really bothering to understand why and how. And if it works so well, maybe it can work too well. And it can be very, 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 very deadly, as all those vendors can attest. There are a lot of areas to explore, a lot of systems that use serialization, deserialization in some sort of unexpected ways or in hidden areas, like the binary message formatter we just saw, which really doesn't say much about that in documentation. And never trust the deserializer. Always test it first. Questions? Yeah, message queuing in general, sure. There are a lot of samples. MSMQ, yes. Yes, I have. I saw that it was in earlier versions of Hangfire, which is a distribution system for .NET. It's supported by BizTalk. It's built into BizTalk, so you can probably see systems that wrap that up. It's actually not, it used to be a little more common. They really stopped supporting it a couple of years ago, but it's still out there. That's the concept. Is the scary concept is that it's going to be part of backbones rather than application. Mm-hmm. So I suppose there is. It's just not really in scope because that's not, that's not deserialization. That's probably going to be something about memory management issues rather than deserialization. But there are. It's actually quite interesting to read. But again, it's kind of out of scope for me. So, I mean, I hope I understand your question. If there are any improvements as a result into deserialization research. So, yes, I mean, it has been fixed for struts. Struts still has a ton of holes in it, but I don't think that the naive deserializer is one of them. It is interesting to try and research, I think, their fix for struts because it's still semi-automatic. Automatically constructs the whitelist. So that's a good direction to go in, I think. But yeah, I mean, remotely accessible deserializers are getting tighter and tighter. That's the end result of this entire endeavor. Anybody else? Thank you. Oh. Selfie challenge. So. Okay. Middle fingers in the air. Come on. Thank you very much.